All right, welcome and thanks again for joining for this optional video. So we're just going to be going through those last three slides talking about composition of functions. Might take just a little bit of time because there's a lot of questions on each one, but make sure that you're paying attention to the actual explanation. So f plus g of x. Remember that f plus g of x just means we're taking the f of x function, 2x plus 5, and adding the g of x function, x squared minus 3x. When I add these two functions that I'm just combining like terms, so I get x squared minus x plus 5. That's it. F minus g of x. So f minus g of x, just a little bit more attention to detail. We still have 2x plus 5 minus, and then I always put that second one in parentheses because what you have to remember is that you're subtracting the entire function, which means that the signs would change. So this becomes 2x plus 5 minus x squared plus 3x. And this is where the issue usually comes in, because if you don't write those parentheses, you sometimes will forget to change that sign. This just goes then to negative x squared plus 5x plus 5. F times g of x. So f times g of x means we're doing 2x plus 5 times x squared minus 3x. So remember here that what you're doing is just multiplying out these polynomials. If you want to think of it as distributing, or if you want to think of it as foiling, you're doing 2x times x squared, which gives you 2x cubed, 2x times negative 3x, negative 6x squared. 5 times x squared is 5x squared, and 5 times negative 3x is negative 15x. Combine your like terms, so you get 2x cubed minus x squared minus 15x. Sorry, this one should just say x. Final answer. So notice these first two, those were just combining like terms. This next one, you're just multiplying two binomials, very easy. F divided by g of x just means f function is in the numerator, g function is in the denominator. We do talk about domain restrictions with something like this because we do have some issues with the denominator. So if you factor that denominator, you'd get 2x plus 5 over x times x minus 3. I just greatest common factored the x out of that denominator. And the only way that this helps us is now what we have to do is state what x cannot be equal to. X cannot be equal to anything that's going to zero out the denominator here. So if x is 0, I'd get 0 times something, negative 3, which would be 0. So x can't be 0. X also can't be 3, because if I put in 3, I'd get 3 times 3 minus 3, which is 0. Any other number, if I put 10 in here, these two things are going to be two non-zero products, and that's what you need. So this whole thing would be the answer. All right, then f plus g of 2. Now we've already done f plus g of x, so I'm just going to use that equation. But what's cool here is that all you have to do now is say, well, this was f plus g of x, so I'm going to substitute 2 into that equation. I get 2 squared minus 2 plus 5. So 4 plus 3, which is 7. Here, f times g of negative 1. I already have my f times g of x function, and all I'm doing is substituting negative 1 into that. Here I get positive 15. Negative 1 squared is positive 1, but it's a minus that, so minus 1. Negative 1 cubed is negative 1, times 2 is negative 2. This gives me 12. All right, very, hopefully, easy, simple things. Jumping ahead, so now, just to look at some more complex composition, we have f of g of x. F of g of x means I'm taking the g of x function, and I'm substituting it in not just for one, but for both of these x's. So I'd get 2 times x minus 2 squared. Realize I replaced x with the entire function, g minus 5 times x minus 2. If you're looking at this new thing that I just wrote compared to the original function, notice that the only thing that is different is instead of writing x, I wrote parentheses x minus 2, and that's because that is what the g of x function is. So I'm going to distribute this negative 5 first. It's just the order that I like to do things in. And then I have to do this x minus 2 squared. You really need to get used to sort of multiplying that out without writing it all out. If you need to write it out, do it, but break away from that. We get x squared minus 4x plus 4. And then we'll distribute this 2 to this. So 2x squared minus 8x plus 8. If you did that in one step, that's perfectly fine. Do make sure that you show some work. So when I combine my like terms, then I get 2x squared minus 13x plus 18. Going the other way ends up being a lot easier. G of f of x. So I'm going to take this f function, and I'm substituting that one into x in my g function. So my g function, I'm only replacing x once, and I'm replacing it with this entire expression, 2x squared minus 5x. So there I just replaced x. The rest of the function then is just minus 2. And that's all. So yeah, just sometimes it works out where there's nothing I have to do afterwards. Sometimes there's a lot of simplifying I have to do afterwards. And then the last thing we want to do is graphically be able to read these. So use the graphs of f and g to the right to find the following. Now the biggest thing with this is that you have to make sure that you're looking at the correct function. Here's my f function. Here's my g function. What I see a lot of people doing, just to sort of help themselves out, is color coding this. So being like, okay, here's my f function. And then here is my g function. Just to sort of help them keep in mind that there are two different functions that they need to switch between. I don't care if that's what you do. You can do that. You cannot do that. So f minus g of 0. Remember that what this means is f of 0 minus g of 0. I should probably switch this to red. So if I do f of 0, that means I'm looking at this pink function. And I go to the value when x is 0. So here, x is 0. The y value or the function value is 4. Minus g of 0, so I'm looking at the blue function, and g of 0 means when x is 0, what is y, which would be 0. 4 minus 0 is 4. F times g of 1. So I'm doing f of 1. Here's 1. F of that means the pink line, so 2, times g of 1. G of 1 is that blue function, so I go to 1. I go up to that blue function, and that value is 3. 2 times 3 is 6. F over g of 2. So I'm going to do f of 2 first, which is right here as 0, over g of 2. So here's 2. I go to the blue function. That value is 4. 0 over 4 is 0. And then last g of f of 1. So I have to start here, f of 1. When I do f of 1, I go to 1. I go up to the pink line, since that's f, and I get 2. What I'm doing then is g of 2. There's no operation now in between these. I'm not going to take f of 1's value and multiply or add it to whatever I get with g. I'm just getting f of 1 and using that as my x. So now g of 2, I start at 2 and I go up to that blue function, that is 4. So your answer here is just 4. No operation to do. All right, that's all for this video. Again, nice short section. Make sure that you start on the homework if you wanted to get started on that. Otherwise, make sure that you know what questions you have so that we can just get started right away.